A typical sample of hydrocarbon-contaminated soil consists of dirt, sand, and clay that is saturated with a mixture of waste oil products. For this demonstration, we have procured soil samples from an oil storage facility comparable to the common mixture of typical components that could be expected to be found at many spill sites. To begin, the contaminated sample is placed in a vessel with water. As one can see, there is no reaction of the contaminated matter in water. Upon introduction of a small amount of Petroluxus 400, one can immediately see a reaction. Oil begins to separate from the soil, and since the specific gravity of the oil is lighter than water, the oil is forced to rise to the top. This test is being performed at ambient temperature without added heat and circulation. Although Petroluxus 400 works most effectively at a temperature range of 80 to 105 degrees Fahrenheit, lower temperatures are not a problem, but the reaction and process time will be slightly longer. This video provides a visual dramatization of how Petroluxus 400 can be used to treat contaminated soil to eliminate the hazardous material contamination, recover the oil, and do both in a cost-effective, efficient, and environmentally friendly manner. Remediation and cleanup projects involving oil and fuel leaks and spills are both hazardous to our environment and groundwater. The cost of remediation to the thousands of affected sites presents a multi-million-dollar dilemma annually, and in most cases, cleanup does not allow for the recovery of the hydrocarbons. It only reduces the waste that must still be treated as a hazardous material for acceptable hazardous waste disposal landfills. Current methods of remediation include treatments with biological microbes or stabilizers for disposal in landfills and/or incineration. Biological microbes digest the hydrocarbons to render the hazardous material inert, but take an extensive amount of time to complete the reaction before being sent to an off-site hazardous waste facility. Incineration involves costly transportation to an incinerator facility and requires extremely high levels of heat to obtain a similar result. All methods are extremely costly, time-consuming, and make little or no provision for the recovery of resalable hydrocarbons. Petroluxus 400 utilizes several unique properties to initiate the separation. Firstly, it uses the water as a carrier and disperses rapidly to maximize its available surface area. Secondly, the chemical has a highly negative conductivity, so when in contact with hydrocarbons, it initiates an ionic exchange process that causes the oil to become hydrophobic. In other words, it cannot hold water, and loses its attraction or bond to other matters such as soil, sand, rock, metals, and other forms of particulates. Thirdly, the oil becomes colloidal and forms into microscopic oil droplets, forcing it to seek the companionship of other oil molecules. Finally, Petroluxus simply makes the oil and particulate matter more slippery, thus reducing the frictional coefficient and effectively eliminating surface tension and bond. All of these properties collectively provide an efficient and cost-effective method of extracting hydrocarbons from contaminated soil, which makes them readily available for collection and recovery. Independent third-party tests have shown that a first wash such as this demonstration will remove over 99% of the hydrocarbons. The remaining hydrocarbons can be further reduced by additional wash phases until the solids and particulate matter are safe for traditional disposal. The water chemical solution that remains is non-toxic and non-hazardous and can be separated out for disposal without harm to the environment. Cost-effective to apply and environmentally friendly final waste residue make Petroluxus 400 a product that meets the demands of responsible remediation practices, not to mention the additional revenue received of recoverable and saleable hydrocarbons. Petroluxus 400 can be used with current equipment technology to provide a total solution to most remediation problems.